Chapter 17, Atmospheric Science, Air Quality, and Pollution Control. The case study is about cleaning the air in Los Angeles and Mexico City. We don't need to sticky note anything here, so let's start here on page 450. You need to know these particular stats of the atmosphere. And again, anything that's on a sticky note is fair game on my exams or the AP test, so you do need to know these percentages here. And we mainly breathe oxygen because it's the most dense, and so it's closer by gravity to the Earth. And so in the lower atmosphere, which is the troposphere, we have mostly oxygen, even though the whole atmosphere is made up mostly of nitrogen gas, and you do need to know this. Up here, you do need to know the 5 layers of the atmosphere in order, and we need to add one of these at top. That's left out of your book, so the star means it's not really in your book, but you need to know it. And we need to also know there's a bunch of things that occur in the stratosphere that your book doesn't go over, but has appeared on previous AP exams, including that in the troposphere we have the most air particles, the most mass, the highest density. Weather occurs in the troposphere, global warming occurs in the troposphere. So basically on an AP exam, if you can't remember which layer of the atmosphere something happens, just pick troposphere because it's the one where most things occur. Except for ozone thinning, and where the ozone layer is, that's actually in the stratosphere, and you can see it on here. This purple represents ozone concentration, which is an O3 molecule, and you can see that the majority is up here in the stratosphere. That protects us from UV rays, but we have some down here in the troposphere that's actually an air pollutant. We don't want to breathe it in. I mean, even up here you don't want to breathe it in, but we're never up here in the stratosphere, so we don't breathe it in, and here it protects us from UV rays. But we are here in the troposphere, and it's created actually from burning gasoline in our cars and transportation. It's not good for us. Okay, page 452, here's some definitions to know. Atmospheric pressure, relative humidity, convection circulation. Know the difference between weather versus climate. And add on to your book is microclimate. So sometimes you have a little bitty area that's different than the surrounding area. It can be small, like the bricks on your house is warmer than the surrounding area, to a few square miles like San Francisco. This is not the whole Bay Area, this is just San Francisco is kind of a small area. It's not big like LA, it's small in terms of square miles, and it has this strange microclimate where it's always colder than even the cities in the Bay Area like Oakland or San Jose. It's always colder in San Francisco. They're at the top of the bay on a peninsula, and fog rolls in and it's always colder. Know this figure and caption how why the equator is hotter than the poles. It has to do with the sunlight has to travel less distance, and it's at a straighter angle, so we have a 90-degree angle here instead of a different angle. And so that makes the difference in terms of why the poles are colder than the equator. So up here you need to know about what causes the seasons. So as the Earth rotates around the sun, we rotate around the sun once per year, and we're actually on a tilt of 23.5-degree tilt on our axis. And so either the northern hemisphere or the southern hemisphere is tilted toward the sun, depending on what time of year you are. And so for us in the northern hemisphere, we have summer in June and July when we're facing the sun, so the northern hemisphere is tilted toward the sun. And then we have winter when we're not tilted toward the sun. But the southern hemisphere is, so Australia has opposite seasons. So in December, in Australia it's summer, but it's winter here. And then you need to know what a convection cell is. So convection cells occur not just with air, but also with water. They also occur with magma, which drives plate tectonics. So basically hot substances rise and cool substances fall in a big loop. And so whenever you have your hot, moist air that rises, as it goes higher in the atmosphere, it's going to cool down and create clouds, and then it's going to rain. But then the dry air is going to go this way and fall. And so this is, for example, the equator, and this is us. So we're about 34 degrees north latitude, and we get this kind of a pattern. Equator goes over to us and falls. You also need to know some weather terms here. High pressure means fair or clear weather, nice and sunny outside, and low pressure is rain, precipitation, or snow, or whatever. All right, so you also need to know what a thermal inversion is, and we have some pictures down here of a thermal inversion. So this is normal conditions, and the air pollution just escapes into the atmosphere. But sometimes it gets trapped because the temperature differences have shifted. So usually this occurs, and your book picture doesn't really show the, so usually it's warm, cold, warm. Your book has it inverted to warm and on top and cold on the bottom, but often it's a cold mass in between two warm masses, and what it does is it traps air pollution. And this tends to happen near coasts where an ocean breeze can blow cool air under warm air, and that's what traps the air pollution. And so it's a physical property of air and water that different temperatures don't like to mix because of different densities. And so that's what traps the air pollution. All right, so another add-on to your book is that we get thermal inversions in Santa Clarita because we have mountains that surround our valley, and this is the same for other valleys too. You know, it can happen in Denver because of the Rocky Mountains. So we get a thermal inversion because in the late afternoon, in the summer in particular, when the daylight's longer, the mountains cast a shadow and cools the city, but the sun is still warming the upper air mass. And so that's when you get this classic thing here, is that the mountains have shadowed this area and it cools down, but then it's still warm up here because it's not night yet. And so we get the thermal inversion and trapping of pollution. And that's what happens in Santa Clarita and other valleys where you have a lot of air pollution. Okay, you also need to know the cause of winds. So the Coriolis effect is the spin of the Earth, and it causes the winds along with convection cells. So the rise of warm air and the fall of cool air every 30 degrees latitude, which is a convection cell, plus the spin of the Earth, which deflects the air. So the Coriolis effect is the deflecting of that air to the side, and that's what causes winds. And so if you know down here, here's our convection cells that we just talked about on the previous page, but now it's showing you at the equator. So at the equator, it rises, it rains down, and then these cold air drops here. And again, we're at 34 degrees north latitude, and this is why our climate is mostly dry, because of the Hadley cell that drops cold, dry air here. And so you need to know, and this occurs basically in these loops all over the globe. And so we have these different ones, polar, feral, Hadley cells, etc. The same thing happens here with the polar cells. So up here in Canada, at about 60 degrees north latitude, it rains a lot, and then that cold, dry air falls on the poles, and you get the tundra, which is basically no rain. So if you remember back to our biomes, tundra gets very little rain, just like a desert. So you need to know the names of these cells. And you also need to know that deserts and other arid climates, so arid means dry, and that's us, we're chaparral, so we're arid. They occur mainly at 30 degrees north and south latitude and also at the poles. But these latitudes are rainy. So 0 and 60 are usually rainy. So you need to know that information. All right, on page 456, know what a hurricane is. A hurricane can go by other names too. So it's a cyclone in the southern hemisphere. A hurricane is in the northern hemisphere and in the Atlantic. It's a typhoon in the Pacific. know what a tornado is and what ambient air pollution is. All right, so now we're going to be talking about air pollution. So this figure and caption shows that we have natural sources of air pollution. It's not all man-made. We can also categorize air pollution by point source and non-point source, just like we did for water pollution. If we can identify a large source and point to it and say, it's that factory, it's that power plant, that's point source. But if it's a bunch of little things mixed together, like a bunch of cars driving together, like in Los Angeles we have, 10 million cars, so all of those cars together create non-point source pollution. Going on to 458. So you need to know the provisions of the Clean Air Act, and this was essential for cleaning up not just Los Angeles, but other cities as well. So it set standards for air quality, which actually we don't really meet still to this day, but it's a lot better in Los Angeles area. It sets emission limits for industry and transportation. So emissions are how much you let out, you emit from your car or your smokestack. And so if you are a factory or a power plant that generates electricity by burning coal, there's only a certain limit that you can allow to emit. It created funds to research pollution, and then it allows you as a citizen to sue a violating party. So if there's a power plant next to your neighborhood, you and your neighbors can get together and sue for damage if they are not following the Clean Air Act. It also allows for cap and trade pollution permits, which we've studied before. All right, so this chapter now goes into all of the different kinds of pollutants, and we are going to in class create a chart for these pollutants because there's some very specific information that you need to know about nitrogen oxides, which we like to call NOx, and then volatile organic chemicals, which we call VOX, and particulate matter, and lead, and there's more here, sulfur dioxide and carbon dioxide. And so we will make a chart with some specifics that you need to know about. Now overall, since the Clean Air Act, things have gotten way better in the United States from all of these pollutants. They've all gone down, which is great for our health. And while they've gone down, our GDP has gone up, so it hasn't hurt the economy at all. So emissions have gone down, but we have more people, we consume more energy, we have more vehicles that we drive, and our economy's gone up even though we've reduced emissions. And so that's a great success story. So what can we do on our cars to remove pollutants? So this is a catalytic converter. When I was a kid, my folks had to put it on the car, but now they all come with them on the cars. But these two items in a car in particular remove carbon monoxide and NO2. What else improves air pollution? So smokestacks. There are two things that can remove certain air pollutants. And again, this is a chapter you have to be real specific. So going back here, you need to know specifically on a multiple choice that catalytic converters remove these two air pollutants. Okay? And then you need to know on smokestacks that wet scrubbers, and this is a picture of a wet scrubber, and you can't just say scrubber, you have to say wet scrubber on like an FRQ. It in particular removes sulfur dioxide from burning coal. An electrostatic precipitator removes particulates. So on an FRQ, you have to specifically know the names of a wet scrubber and an electrostatic precipitator. You can't just say scrubber, and you can't say a filter, because filter is kind of an ambiguous term that doesn't really mean anything. So you need to specifically know those terms. And we will continue on with the next video and the next page.